Michigan, the Great Lake Blue Water State, has over 36,000 miles of streams, including over 12,000 miles of cold water trout streams and more than 11,000 lakes and ponds. Our waters like air, owned by no one and yet owned by all, being defined as waters of the state. The state's water resources are protected by the Water Bureau of the Department of Environmental Quality and partnering organizations who determine the water quality, the quantity and quality of aquatic habitat, the health of aquatic communities, and compliance with state laws. Our two peninsulas are surrounded by four of the Great Lakes: Superior, Michigan, Huron, and Erie. The combined Great Lakes contain 90% of the United States and 1/5 of the world's surface fresh water. The water in the Great Lakes could cover the entire United States with over 9.5 feet of water. They are large enough to influence the regional climate, cooling summers and tempering winters, as well as increasing amounts of rain and snow in the region. They are the centerpiece of the largest freshwater system on the face of the earth. They hold the key to the economic prosperity, environmental health, and quality of life of tens of millions of residents. Our surface waters, such as lakes and streams, and our groundwaters are used for several purposes. Our waters afford us an abundant source of drinking water. In addition to the use of the Great Lakes by many municipal drinking water systems, Michigan has 1.12 million households served by private wells, more than any other state. We have approximately 1,500 community public water supplies and 11,000 non-community public water supplies. Our waters and the approximately 3,288 miles of Great Lakes coastline, with its many sparkling sandy beaches, provide great opportunities for recreation and a world-class sports fishery. We have readily available water for manufacturing and agriculture, and additionally our waters provide a major thoroughfare for shipping. We have also used our waters as a means to dispose of our wastes. Wastewater from all Michigan's residents is discharged into surface water bodies or into groundwater and eventually finds its way to the Great Lakes. Small communities and large cities alike generate wastewater and must provide treatment works to treat the wastewater they produce. Historically, wastewater treatment involved little more than tanks where solids settled out prior to discharge of the wastewater into a river. Now, municipalities utilize biological treatment systems to clean their wastewater before it's discharged back into the environment. In biological treatment, air is introduced into the wastewater to promote the growth of naturally occurring beneficial microorganisms. The most common form of aerobic biological treatment is called the activated sludge process. There are other types of aerobic treatment, but all of them involve the same types of microorganisms that feed on bacteria and other substances in the wastewater and thereby remove it from the wastewater. The excess microbes are then settled out of the water and the water is discharged back to the environment. Then the treatment plant must do something with the biological solids or biosolids that have been removed from the wastewater. There are approximately 170 facilities that further treat the biosolids to reduce pathogens and then recycle the biosolids on land. The application of biosolids on land is regulated by the Michigan DEQ and the United States Environmental Protection Agency to provide protection to the environment and human health. The study of the potential for public health risk has resulted in regulations that are protective of public health and the environment and must be followed when biosolids are land applied.
We use a multi-pathway risk assessment to determine under worst case conditions what the dosages of various pollutants would be to what we call a highly exposed individual. We use the concept of a highly exposed individual to represent a person that if that person is protected from the standards, then the general population is protected with even a greater margin of safety.
The recycling of biosolids by application to the land has been extensively researched to assure that human health and the environment are protected.
There have been very extensive programs looking at long-term biosolids application to the land, primarily conducted by land-grant universities through the cooperative extension service programs across the country, looking at all types of agricultural use practices and even forestry and reclamation of disturbed sites and contaminated sites. Some of these programs go back 30, 35 years and have had continuous records as far as the potential benefits and evaluating the potential hazards associated with biosolids use in land application programs.
And basically what we were doing was looking at loadings of cadmium to soils, and we used a sewage sludge back in the late 70s that came from the city of Chicago. They had a sewage sludge that was relatively high in cadmium, and so we were looking at 100 metric ton per acre rate compared to 5 years of 20 metric ton per acre applications to see if there were differences relative to plant uptake. And the concern with cadmium is passing along a non-essential element or metal into the food chain. And so as agronomists, we were trying to address the uptake and looking at and trying to better understand the amount of cadmium uptake that would occur in various plants relative to the total loadings of cadmiums that were made from those sewage sludge applications. Cadmium is one of the metals that was of great concern back in the late 70s, early 80s when we had high concentrations of metals in what we would call sewage sludges. From that time period, we've seen an increase in the quality of biosolids and the metal levels because of pre-treatment control and so forth in wastewater treatment plants. That's really lowered those kind of background levels to something that's not much different than what we would expect to find in animal manures, and sometimes even less than what we get in animal manures.
For the last 20 years, the state of Michigan has worked with local governments and wastewater treatment facilities to implement the industrial pretreatment program.
A wastewater treatment plant receives different types of waste: industrial, commercial, and domestic wastewater. These types of waste are something that need to be controlled in order to prevent problems at the wastewater treatment plant.
Besides recycling on land, solids from the wastewater treatment plant process may be disposed of in Type 2 landfills along with municipal solid waste, or they may be burned in incinerators and the resulting ash disposed of in landfills. These methods of disposal have their own unique impacts on the environment. One of the goals of the DEQ has been to divert material that can be recycled from these disposal methods into beneficial reuse programs. The industrial pretreatment program has been very successful in reducing the amount of pollutants in biosolids in Michigan to the point where the average pollutant concentrations in Michigan biosolids falls far below federal threshold levels for application to land. As a result, the vast majority of Michigan municipalities use recycling of biosolids on land as their method for biosolids handling.
We've been using biosolids on our farm for now about 22 years, and we've saw a tremendous increase in the amount of production and the quality of the hay crop off the land. We find that we at least in fields where we didn't use biosolids before, we were getting about half of the production that we're getting now with the use of biosolids. We've been pasturing cattle as well on our land for all the time that we've been applying the biosolids, and we have almost 100% calf crop from our 44 cows, and there doesn't seem to be any deleterious effects for the cattle or their reproductive activity while we're using the biosolids. The only thing, every once in a while we'll find a tomato plant out in the middle of our hayfield, but the tomatoes never get a chance to ripen, so I guess that's not a bad thing.
Biosolids contain the three primary crop nutrients: nitrogen, phosphorus, and potassium, as well as several other nutrients such as calcium, magnesium, sulfur, copper, iron, and zinc. By using biosolids, farmers are able to replenish the soil's organic matter and help maintain long-term productivity of the soil. To protect the groundwaters from excessive nutrients leaching and surface waters from nutrients running off, Michigan's rules require that biosolids be applied at an agronomic rate, being the rate that is equal to or less than the amount of nitrogen needed by the crop to be grown. This application rate provides a time-release source of organic nitrogen that becomes available slowly throughout the growing season as soil bacteria break down the biosolids, and minimizes the amount of nitrogen that passes below the plant's root zone where it may impact the groundwater. In contrast, the inorganic nitrogen in commercial fertilizers is immediately available at the start of the growing season and has a greater chance of leaching away in the soil. In addition to supplying benefits to agricultural soils, biosolids have been used successfully in land reclamation projects.
We used to landfill our wastewater biosolids in Rogers City, which was a difficult way to dispose of biosolids. We had to dry them in drying beds and then truck it and landfill it. But after the project of using biosolids on forest land in Montmorency County was completed by Michigan State University, the EPA, and the DEQ, with DEQ encouragement, we started a biosolids land application program on Michigan limestone quarry property, and you can see the results of the fields that we're now land applying the biosolids. This is an area here, this field, that we have not applied biosolids to, and they would like us to, in the future someday, take a look at applying biosolids to this field because we've had such great success with the other fields. This area here is actually an overburden dumping ground. It's basically the material that was not mined. It's off the surface and it has no value, so they would mine it, take it off, strip it off, and dump it in piles here. And then once we decided to start land applying biosolids to this 40 to 60 acre site, they leveled this overburden material off enough so that we could get our trucks on it, and we applied biosolids on this 60 acre site probably close to 10 years. And as you can see, now there are all kinds of different shrubs, trees, grasses growing, and the wildlife are up here, which is kind of unique because the entire area is surrounded by quarry. So the wildlife have to go across open quarry to get up here on this site so that they can utilize the plant growth.
Whenever biosolids are recycled on land, protecting human health and the environment is one of the highest goals of Michigan's biosolids program. What happens on land, be it farm land or reclamation land, can have a direct impact on Michigan's lakes and streams, and ultimately the Great Lakes. Biosolids applications to land have specific regulations that must be followed, such as prohibition against surface application on frozen or snow-covered ground to protect local surface water bodies from runoff. One exception is when the ground is snow-covered but not frozen, so that biosolids may still be injected into the soil. The other exception is if biosolids are applied to the surface of the soil and can still be tilled into the soil following spreading. Farmers cooperating with municipalities in Michigan have successfully shown over the past 25 years that biosolids recycling can work and work well.
Many farmers are already familiar with the application of our animal manures or those types of organic materials. Some have even applied food processing residuals and other types of organic materials to their land in the past and have some experience with them. As a result of that, most farmers are happy to get those materials and make use of them on their land. In fact, in areas where there's a lot of farmers interested in the use of biosolids, oftentimes they really rather not tell their neighbors because they prefer to use as much of these materials on their own farmland rather than sharing them with some of their farmer neighbors. So by and large, when we're looking at farmers, they become some of the best spokesmen for the use of these materials and passing the word along in the agricultural communities that these materials are good products to use, and in doing so we're getting not only nutrients but also some organic matter that's going back into the agricultural soils as compared to the use of just inorganic fertilizer nutrients.
The slogan of the DEQ is protecting Michigan's environment, ensuring Michigan's future. The recycling of biosolids is one example that shows that we have the ability to take what was a waste and put it to productive use.
The long-term evaluation of this has suggested that we can have sustainable programs on many different types of land application systems.